In this video, we're going to focus solely on inverse functions of exponents as well as parabola. Inverse function implies it's a reflection in the line y is equal to x. So how do we get this function? We merely interchange all x values for y values. So whatever was y value becomes x value and vice versa. We also interchange the domain of f of x to become the range of f to the minus 1. Here, to show that it is an inverse, we do not call it f of x. It now becomes f to the minus 1 of x. Do not confuse this with f prime x. Do not confuse it with f prime x, because those two things are not the same. F prime of x is the derivative, whereas f to the minus 1 is the inverse. And inverse simply means it's a reflection in the line y is equals to x. It's a special type of reflection in the line y is equals to x. For notational reasons, the inverse is known as f to the minus 1 of x. It could be g to the minus 1 depending on what the function was. So it could be m to the minus 1, n to the minus 1, g to the minus 1. But it's got a minus 1. Do not confuse it with f by x. The first inverse that we're going to look at is the logarithmic function. The logarithmic function is the inverse of the inverse function. And in this case, if f of x was equal to b to the x, then the inverse log function is f to the minus 1, which is equals to log to the base of b of x. Make sure you put the brackets there. It preserves the function for you. Here's an example. If f of x was going to be 2 to the x plus 4, then the inverse, how do you get the inverse? Step number 1, interchange x and y. So y was equals to 2x plus 4. Interchange x and y. Interchange, that means wherever there is x, now put y, wherever there is y, now put x. So in place of this y, I'm going to put x. In place of this x, I'm going to put y plus 4. That is the interchange. Thereafter, use algebraic manipulation to make y the subject. Here, the algebraic manipulation required there comes from laws of logarithms. We have an unknown exponent. To change an unknown exponent and make it subject of the formula, you would have to use logarithms. So, x is equal to y plus 4 is equals to log 2 was the base, so it goes underneath there. Then in brackets you put x. In brackets you put x. X was the number. So that means y is now equal to log to the base of 2 x, x in brackets on its own, minus 4. But to simplify it, we then say f to the minus 1 of x is equals to log to the base of 2x in brackets minus 4. That is the inverse. That's how you get the inverse of that. Which are the two steps that I'm emphasizing here? Steps to get inverse. Number 1, interchange x and y. When you interchange, this y became x and this x became 1. That's a mark. Then here, you get marks for your algebraic manipulation. You had an unknown exponent, so you had to use logarithms with a base of 2 to be able to make y the subject. So that is the second key step there. On average, there are 2 marks for this in an exam, but it could be 3 marks depending on the number of manipulations required. If you were to sketch the log function, sketching the log function, if the original exponential function was increasing, then the inverse log function should also be increasing. Conversely, in the same manner, if the exponential function was decreasing, then the log function will also be decreasing. Usually, sketching the line y is equals to x as the axis of reflection helps in accuracy. So if we had this one, if we were to sketch this function, this is the xy plane. This is y, this is x. The first thing we need to do is sketch the asymptote. The asymptote was 0 since q was 0. So y is equals to 0 is just known as the x-axis. So y is equals to 0. That is the asymptote. Then you look for the y-intercept. If you put 0 there, y-intercept simply means x is equals to 0. Y is equals to 2 to the 0 plus 4. This is equals to 2 to the 4. Y is equals to 16. Y is equals to 16. Here is 16. What type of function was this? Was it increasing or decreasing? It was a strictly increasing function. Strictly increasing function. This is f. And it had a point. Mark that point out. That point was 0 for x and 16 for y. If you wanted to sketch its inverse, it would help. The point I'm making here is it would help if you mark out the line y is equals to x. It goes through the origin. Y is equals to x. Then all you do is remember that x and y values are merely interchanged from one function f of x to another function f to the minus x and vice versa. So we have one point. That one point was 0 and 16. We now need to interchange. This 16, which was y, becomes the x coordinate. Let's assume that is happening at this point here. That point is now 16, and this x coordinate, which was 0, becomes the y coordinate right here. And we mentioned to say if one function was increasing, the other function will also increase. So the corresponding inverse function is going to increase like that. And this is f to the minus 1 of x. F to the minus 1 of x increasing. And this purple graph, its asymptote is no longer the x-axis. Funny enough, its asymptote is now the y-axis. Because everything about y and x has been interchanged. Everything about y and x has been interchanged. There are a couple of things that we also need to analyze. What happened to the domain and the range? So, domain, we have f of x and f to the minus 1 of x. In terms of domain, the domain of this one was x in real. It becomes the range of this one, which is y in real. I merely interchanged x and y. Then the range of this one, the original graph, was above y is equals to 0, so y greater than 0. It becomes the domain here, x greater than 0. X greater than 0. That's how those two functions affect each other. Everything in terms of x and y is interchanged, even affecting domain and range. And this is how you would sketch it as accurately as you can. Let's do some examples of the log function. We're given h of x as log to base a of x. Log to base a of x. And we know the base is non-positive, non-negative. That's why we are saying a is greater than 0. We have a point that is on this function. That point is s, which is 1/3 and 1. Show that a is equals to 3. 6.1. You substitute. You substitute this in place of x. You substitute this in place of y. H of x is y. So y is equals to log to the base of a of 1/3. Y was just 1. So what does this do? The base goes and raises that 1 to the power, so it's now a to the 1. The log disappears. I now have 1/3. Sorry, that one, negative. Negative 1. Laws of logarithms, a to the negative 1 is as good as 1 over a is equals to 1 over 3. Cross multiply, the 3 multiplies 1, a multiplies 1. That means 3 is equals to a as was required. A is equals to 3 as was required. Write down the domain of H. Domain is such that x is in real. No exclusions, since it's got no asymptotes. Determine the equation of f to the minus 1. Sorry, h to the minus 1. This is the inverse. So 6.3. We now know h of x is equals to log to the base 3 of x. Y is equals to log to the base 3 of x. Step number 1, interchange x and y. Wherever there is a y, put x. Wherever there is an x, put y. Step number 2, the base goes and raises x. So this is 3 to the x leaves y. But they don't need it in that format. They needed it in the format h to the minus 1. So this is h to the minus 1 of x is equals to 3 to the x. That is our inverse function. That is our inverse function. Is h to the minus 1 a function? Yes. Is h to the minus 1 a function? 6.4. Is h to the minus 1, the inverse, a function? Answer, yes. Why? It has a 1 to 1 mapping. It has a 1 to 1 mapping. Therefore, satisfies the vertical line test. So yes, it is a function because it passes the vertical line test. Next up, 6.5. S prime, the image of S lies on h to the minus 1. Write down the coordinates of S prime. We already know what S is. And we said moving from one to the other, we mentioned it right here, when you move from one to the other, it is key to remember that x and y values are merely interchanged from one function f of x to another f to the minus 1. So in the same instance here, if you are moving from S to S prime, you merely have to interchange the x and y values. So S prime is minus 1, 1/3. Lastly, determine the values for which log to base 3 of x is between 1, 0 and 1. Log to the base. So, if we're asked to deduce this, determine the values for which this is true. We can do it with the graphical approach. The graphical approach is going to be like this. This point is 1 in terms of x, and it continues in that fashion. This is the function log to base 3 of x. Where is this function having a y value of 0 up to 1? 0 up to 1, here is 0, then 1 here. If it's got a value of 1, it's going to be 1 is equals to log to base 3 of x. This is going to be 3 is equals to x. 3. So between 1 and 0, this is 1. That's another way to solve it graphically. If you can sketch the function. If you can't sketch the function, let's solve it algebraically. So you can solve it graphically, like I've done, or you can solve it algebraically. So solving it algebraically, you would require grade 10 methods of inequalities. So we have 0 less than log to base 3 of x less than 1. This 3 is going to be raise 1. It's also going to raise there. So next step, this implies 3 to the 0, 3 to the 1. Anything to the 0 is as good as 1. Same answers. Same answers. Here, it was 0 for y, and here it will be 1 for y. So if we're going to have 0 for y and 1 for y, it is because x was taking the values from 1 to 3. X was taking the values from 1 to 3. That's how you solve it. We solved it graphically and algebraically. So that is the end of that question. Doing the next question, we have h of x is equal to negative h of x is equal to 2 to the negative x. Sketch a neat graph of h. If you are sketching this, it's because the asymptote is 0. So in the xy plane, this is also the asymptote. Y is equal to 0. Then we need its x-intercept. We need its y-intercept. Y-intercept implies x is equal to 0, so y is equal to 2 to the minus 0. It's just y is equal to 2 to the 0, which is 1. Y is equal to 1. Thereafter, we need to figure out the shape. Because x is negative, this is as good as saying h of x is equal to 2 to the minus x. H of x is equal to 1 over 2 everything to the x. We said earlier on, if the base is a fraction, if the base is a fraction, then it will be a decreasing function. The base is a fraction, then it's a decreasing function. If it's decreasing, then it's going this way. This is the function of h. This is the function of h. It's a decreasing function because of this negative. This negative, using laws of exponents, would have made the base negative. If the base is negative, then it's a decreasing function. Determine the equation of q, the graph obtained by reflecting h in the line y is equal to 0. The line y is equal to 0 is otherwise known as the x-axis. Line y is equal to 0 is otherwise known as the x-axis. So reflecting in the x-axis makes y negative. So g of x is equal to minus h of x. G of x is equal to minus h of x. That means g of x becomes minus 2 to the minus x. Another way to express the same thing is minus half to the x, depending which one you choose. Doesn't really matter, it's still the same thing. This was 6.1 and this is 6.2. 1 mark. Write down the equation of h to the minus 1, the inverse. If we're doing the inverse, 6.3, we have y is equals to 2 to the minus x. With y is equals to 2 to the minus x. Step number 1 of finding an inverse is to interchange x and y. Then, thereafter, you're going to get negative y is equals to log to the base of 2 of x in brackets. This is going to be y is equals to negative log to the base 2 of x. This is one way of doing it. Another way of doing it is to use the fractional aspect. So you would have said y is equals to half to the x. Interchange x is equals to half to the y. Next up, y is equals to log to the base of half of x. That's another way. Same answer. Same answer for 6.3. No matter which approach you use, it's still acceptable. Write down the range of h. Write down the range of h. According to the sketch, the graph is strictly on top of the x-axis. Therefore, 6.4. 6.4, the range is such that y is greater than 0. Strictly greater, not equal to. Sketch the graph of h to the minus 1 on the same set of x's. On the same set of x's, we say it is good practice to start by sketching the line y is equals to x. This is the line y is equals to x. Then the original function of h was a decreasing function. We have 1 point. That point was 0 for x and 1 for y. If I interchange x and y, I'm going to have a point 1 for x and 0. 1 for x and 0. And then the asymptote becomes the y-axis. That is now the asymptote. X is equals to 0. And this function will be a decreasing function. Because this was a decreasing function, then h to the minus 1 is a decreasing function. It's decreasing like this. And this is h to the minus 1. H to the minus 1 of x. H to the minus 1 of x. A decreasing function. That is key. Let us make the mistake of making it this way. That would make it an increasing function. And it will be wrong. Because h was decreasing, then h to the minus 1 has to be decreasing at that point. The last question, determine the value or values of h of minus 1 which are greater or equal to minus 3. Greater or equal to minus 3. Using graphical approach, I want to use graphical approach. The values have to be above minus 3. So if this was minus 3, I interpolate until I get to the x-axis. When I get to the x-axis, I interpolate from y-axis up until I get to x-axis. Then it will be all the values on the left, all the values on the left of that point here. So minus 3 is equal to, what was the inverse? The inverse, it was minus log to base 3 of x. So I start by dividing both sides by that, and I will get 3 is equals to log to base of 3. 3 to log of base 3, then this will rise to that 3 to the 3, and this will be equal to x. 3 to the 3 is equal to x. So x is equals to 27. X is equals to 27. Conversely, if you had used y is equals to half to the x, you are going to get log. Okay, x is equals to half of x, half of y, sorry, then this is equals to y is equals to log to the 1/3. This was 2. So this is 2 to the 3, which makes it 8. If you use this one, same thing. Y is equals to log to the half of x. Therefore, its y value to be -3. -3 is equals to log to the half of x. This was going to be half to the -3 is equals to x. X was just going to be 8. Two different approaches, same answer. Two different approaches, same answer. So the corresponding value here was 8. The corresponding value was 8. And they said determine the values of x for which. And those values of x are x less or equal to 8. But strictly greater than 0. Strictly greater than 0. Those are the necessary values. So, what did I do? I took the two different inverses, depending on what version you had. If you had minus log to base 3 of x, you still got x is equals to 8. That was the corresponding x value. And for it to be greater than -3, you had to take all the values on the left, which is, this is asymptotic, so from 0 to 8. That's why I'm concluding this. If you had used this one, I first found the inverse. So, log to the base of half of x. In place of this y, I put -3. Then I solved for x, I still got 8. You interpolate and you go to the left, because that's the point where it was greater than -3. That concludes the second question. Let's do that question right there. We have h of x is equals to 16 to the x. Show algebraically that h of x plus 1 is equal to 4 of h. So I have to do two different things and ensure that they're equal. Left hand side is equals to h of x plus half. This is equals to 16 to the exponent x plus half. Using laws of exponents, this is equals to 16 to the x dot 16 to the half. 16 to the half is 4 dot 16 to the x. If you want, you can take it a step further and say 4 to the 1 dot 4 to the 2x. Final answer, 4 to the 1 plus 2x using laws of exponents. That is the left hand side. Right hand side, we have 4 of h of x. 4 times h of x. H of x was 16x, which is equals to 4 to the 1 dot 4 to the x. This is 4 to the 1 dot 4 to the 2x. Final answer, this is 4, 1 plus 2x. Therefore, left hand side is equals to right hand side, as required. Calculate showing all calculations. Calculate showing all calculations. Here, this is functional notation where I am simply substituting x plus half wherever there was x. So I removed this x and put x plus half. That's what I did. Then I used laws of exponents to break it up. This is 16 to the x dot. Because of the plus, it means they were multiplying. 16 to the half. 16 to the half is root of 16, which is 4, dot 16 to the x. I changed 16, it's not a prime number. Bases should be prime numbers. This is 4 squared. X, then I use laws of exponents. This 4 simply multiplies. I change the base from 16 to 4 squared. And I'll end up having the same answer. I could have even stopped right here. Because it's similar. I could have stopped right there. Okay, moving on. Calculate showing or working. H to the quarter, h of quarter, plus 2 h to the minus 1 of 4 minus 4 to the 0 is equal to h to the half. This is 16 to the half plus 2 y is equals to 16x. To find the inverse, first interchange x is equals to 16 to the y, then log to the base of 16 of x is equals to y. So this is 2 times log to the base of 16 of 4 minus 1. Anything to the base of 0 is 1. So I first calculated the inverse here, then I substituted. 16 to the half is root of 16 plus 2. Using laws of exponents, this 2 can go and become the exponent. Log to 4 squared of 16 minus 1. This is 4 plus log to base 16 of 16 minus 1. Using laws of logarithms, log to 16 of 16 is 1 minus 1. Final answer, it's 4. Final answer, it is 4. I was using a combination of laws of logarithms and laws of exponents. This part, it's laws of exponents. That's just root of 16, which is 4. This part, I took the 2. I first found the inverse. Here is me finding the inverse. After that, I merely substituted to say if x was said to be 4, that becomes 2 log to base 16 of 4. But this coefficient of the log can become its exponent. That's what I did there. 4 squared becomes 16. 4 to the 0 is just 1, 1. So log of 16 to base 16 is 1. So now I have 4 plus 1 minus 1. That's just 4. Now let's get to the second type of. Let's do this question right here. In the diagram, we have f of x is equals to log to the base a of x. Then g of x was equal to f to the minus 1. That means y was equal to log to base a of x. Interchange x and y. X is equals to log to the base of a of y. This means a to the x is equals to y. Therefore, g of x is equals to a to the x. This is me finding the inverse so that I can relate the two. So g of x is equals to that. The two functions are drawn, they intersect, we're given 2 points. Point P, which is 2n minus 1, is a point on F. The two graphs intersect at T. The two graphs intersect at T. Determine the value of A. P is a point on F. P is a point on F. Y is equals to log to the graph, or to the base of A, x. Using P, which is 2n minus 1, means minus 1 is equals to log to base A of 2. A to the minus 1 is equals to 2. That means 1 over A is equals to 2. A is equals to half. Therefore, f of x was actually equal to log to base of half of x. Then, therefore, g of x was equal to half to the x. The equation of g in that form, I've already answered 2 questions. This is A, this is the second one. H of x is equals to log to the base of 2x. Describe the transformation from f to h. Describe the transformation from f to h. This is a reflection in y-axis. Sorry, a reflection in the x-axis. Reflection in the x-axis. It's a reflection in the x-axis. Why? Because log 2 base half of x is just equal to minus log to base 2 of x. These two things are equivalent according to laws of logarithms. Determine the values for which f dot g is less than 0. F dot g is less than 0. This is a product. The only way you can get a product being negative was if they were both, one was positive, one was negative, or negative and positive. Negative implies this is below the x-axis, and positive implies it's above the x-axis. So what we desire here is a scenario whereby one of the graphs is above the x-axis while the other is below the x-axis simultaneously. The graph of g will never be below the x-axis. The graph of g will never be below the x-axis, so we need g to be positive. This is the only plausible scenario where g is above and f is below. This started from that point. So we take the graph of f and find its x-intercept. The graph of f and find its x-intercept. X-intercept means y was 0, so 0 is equals to log to the base of half of x. This is going to be half to the 0 is equals to x. X was equals to 1. So to answer this question, this is happening from 1 going to positive infinity. So this is x greater than 1. This is happening at x greater than 1. Greater or equal to, because they are less or equal to. The range of g of x less than g of x minus 2. G of x minus 2 is equals to half to the x minus 2. Its range simply means that y, range is such that y is to be greater or equal to, strictly greater than minus 2. The range is such that y has to be strictly greater down minus 2. Next, P is the equation of f to the minus 1 shifted 1 unit downwards and 2 units to left. P of x is equals to f to the minus 1 shifted 1 unit downwards and 2 units to the left. So that's x plus 2 minus 1. P of x is the function equation of f to the minus 1 shifted 1 unit downwards. This is 1 unit downwards and shifted 2 units to the left. 2 units to the left, this is it. Plus means you're going leftwards by 2 units. But f to the minus 1 was otherwise known as g. So this is the same as g of x plus 2 minus 1. Therefore, P of x is equal to half to the exponent x plus 2 minus 1. This is the equation of P of x. That is the equation of P of x. Lastly, calculate the value of x if f of x is greater than 2. Calculate the values of x if f of x greater or equal to 2. F of x was log to the base of half of x greater or equal to 2. This will go and kick that up. X will be greater or equal to half squared. This is x greater or equal to 1/4. This is x greater or equal to 1/4. This is x greater or equal to 1/4. We can also use a graphical approach of interpolation. And there is the graph. F was in this fashion. This was 1. Then we had a point P, which was 2 and minus 1. That means here it was minus 1, then there it was 2. Then they want the graph of f to be above 2. If the graph of f is above 2, then here's 2. You interpolate. And they want the x value that goes with this. The x value that goes with that point. So if it's going to be above 2, x had to be not less than, or not greater than, but less or equal to. Less or equal to. So 2 is equal to log to the base of half x. And this had to be half squared is equals to x. X is equals to 1/4, which is the point you're going to get there. So this accurately was between 0 and 1/4. 0 and 1/4. If you use the graphical approach, it gives you more clarity on the changes that are happening in the function. You'll get more clarity on that. That concludes this section on inverse exponential functions.